Hey everyone, welcome back. Today we're going to pull back the curtain on one of the most important pieces of tech that powers our digital lives, database replication. You know, it's kind of the secret sauce that makes sure your favorite apps are just always there when you need them.
I mean, really think about it for a second. How do these massive services, with literally billions of people hitting them all the time, handle all that traffic, server failures, you name it, without even blinking? Well, the answer is a really elegant idea in system design, and that's exactly what we're going to break down today.
All right, so here's our game plan. We're going to start with the huge problem these companies face, then we'll define the solution, replication, and get into the nitty-gritty of how the most popular model works. We'll also talk about the catch, because there's always a catch, and then we'll see how this whole system plays out in the real world.
Okay, let's dive right in. First things first, what in the world is replication? Well, at its core, it's the brilliant answer to the question, how do we keep this thing online 24/7 no matter what happens?
The idea itself is actually super simple. Instead of having just one database that holds all your precious data, you create a bunch of identical copies of it and keep them all in sync. It's really just safety in numbers.
And this analogy just nails it. Imagine you have all your important notes in a single notebook. If you lose it, you're done for. But if you have several perfect copies stashed in different places, losing one is, annoying, but it's not a disaster. That's exactly the thinking behind database replication.
So why do we go through all this trouble? Well, it pretty much boils down to these 4 big wins. You get high availability, which means if one server dies, another one just picks up the slack instantly. You get fault tolerance, so you can survive hardware failing without losing data. And this is huge. You get way better performance and scalability because you can spread out all the work, letting you serve way more people way faster.
Okay, so that's the what and the why, but how does this all actually work? Well, the most common way to set this up is something called the leader-follower model. So let's break down step by step how this thing is put together. So here's what happens every time new data comes in. Step 1, your app sends a write, like a new social media post, to one specific database that we call the leader. The leader is the boss. It processes that new information and then, crucially, it writes down that change in a special log. From there, all the other databases, the followers, are constantly watching that log. They see the new change, pull it down, and update their own copy. And boom, eventually everyone's on the same page.
Now here's the real magic trick. It's this clever split between different kinds of work. Anything that changes the data, we call those writes, has to go to the leader. Only the leader. This keeps everything orderly and prevents chaos. But anything that just looks at the data, we call those reads, can go to any of the followers. And this is the secret to scaling. You can offload that huge, massive fire hose of read requests away from the one super important leader. This makes it perfectly clear. Think about it. You post one photo. That's a single, simple write operation. It goes to the leader. But then, maybe millions of your followers view that photo. That's millions of read operations. And all of those can be spread out across all the follower databases. I mean, without this split, the whole system would just fall over.
All right, so this system sounds pretty incredible, right? It's like the perfect solution. But as you know, in engineering, there are no silver bullets. Every powerful solution comes with its own set of challenges, its own trade-offs.
So let's just ask the question straight up. If this whole setup is so great, what's the catch, right? Where are the hidden problems we have to deal with?
And here it is, the #1 headache, replication lag. See, it takes a little bit of time for a change on the leader to travel across the network and get updated on all the followers. So the followers are pretty much always a tiny bit out of date. Usually we're talking milliseconds, maybe a few seconds. But under heavy load, that lag can grow to minutes, and that can cause some interesting situations.
And I guarantee you have experienced this yourself. You post a comment on a website, hit refresh immediately, and it's gone. Where'd it go? Did it fail? Nope. What happened was your comment, went to the leader just fine, but your read, the refresh, got sent to a follower who just hadn't gotten the news yet. This whole idea is called eventual consistency, and it's a fundamental trade-off you make with this kind of system.
This table sums it up perfectly. For every awesome benefit, like having your system online 24/7, there's a cost, like having to manage a way more complex system. You get disaster recovery, but you pay for it in storage costs. And you get amazing performance for users, but you have to build your app to handle the fact that it might sometimes read slightly old or stale data. It's always a balancing act.
So now that we've got the theory and the trade-offs down, let's bring it all home. Where is this powerful system actually being used? The short answer? Pretty much everywhere. Just think about a big online store on Black Friday. When you actually place an order or the website updates its inventory, that's a critical write that has to go to the leader. But when you and millions of other people are just browsing products, searching for stuff, reading reviews, all of that is read traffic, and it can be handled by the army of followers. This separation is what keeps the site from melting down, making sure the really important stuff, like taking your money, always works.
And look, this isn't some niche, obscure tech. The absolute biggest names in the business are built on this model. We're talking MySQL at Facebook and YouTube, Postgres at Instagram and Spotify, Cassandra at Netflix. Replication isn't just an idea. It's a fundamental building block of the internet as we know it.
So what does all this complexity get you in the end? It gets you a number like this one. People call it 4 nines of uptime, 99.99%. Do you know what that means? It means the system is down for less than 1 hour per year. That's the mind-boggling level of reliability that replication makes possible.
All right, so let's boil it all down. If you walk away with anything today, remember these things. 1, replication is just about keeping copies for safety and for speed. 2, the leader-follower model is the most common way to do it. 3, the whole point is to scale out all those millions of reads by keeping them separate from the writes. And 4, and this is the big one, you always have to design your systems knowing that replication lag is a real thing you have to deal with.
And that brings us to one last thought to chew on. We've seen how the leader-follower model is just brilliant for handling millions, even billions of people reading data. But what happens when your app gets so popular that your single leader can't keep up with all the people writing data? How do you scale when you have millions of writers? Well, that is a much bigger problem and a story for another day.